So for the first part of this point cloud workshop, we will be looking at instancing. If you already know what instancing is and how it works, you can easily skip this part, but as it's such a cornerstone for dealing with point clouds, I thought it might be a good idea to look at the why and how of instancing. You might, as there are quite a bit of changes in the latest experimental build, you might want to check out the end section of this video where I'll be looking at the new features we added to instancing in the 30K series. All right, so what we'll be doing in this section of the workshop is trying to create something like this. We have a box that's subdivided, and onto each subdivision there is another box copied onto. The color of each box that copied onto these box vertices is colored by a noise top, and it's a 3D noise, so we'll be using lookup into a 3D noise to fetch these colors and then be able to animate them. Similarly, the scale is applied also from the color from the noise. Before we do that though, let's have a look at why instancing is interesting. And we can try to create the same thing that we're doing with instancing here with just with SOPs, a different workflow basically. And the SOP that comes to mind that we could use for this is the copy SOP. But let's start from the beginning and let's create a box, which will be the box that will be copied onto many different points. And these many different points will be another box where we turn the divisions on. And 3 by 3 by 3 is fine. That means we now have, that should be 27 different points. Actually 64, whoops. Don't ask me. Oh, it's 4 by 4 by 4, yes. So let's just put a copy SOP here. Copy. The first input of the copy SOP is the copy data, and the second one is the template. And the first thing that's visible here is that these boxes are rotated, and there is an option in the copy SOP. The parameter is called rotate to normal. If we turn this off, we should be seeing just a solid box. Now this is because the size of the copy data is 1, and the size of the template data is 1 as well. So let's go ahead right away and decrease the size of our copy data quite a lot until we see these 4 by 4 by 4 boxes here in the copy SOP. So this is all fine and dandy, and we kind of created the same idea of our instancing, but let's try to apply color to this whole thing. And I said we would be using the noise top. So let's have a look at the noise top for this. There's the noise top, and as you can see, it's a simplex 3D noise, so I somehow should have access to a 3D coordinate in here, but the texture is very 2D as from what you can see. Now the thing with the simplex 3D noise is that it creates, you can best describe it maybe as a box, and into the box you put a lot of records, and each record is a slice in the box. So now if you specify a 3D coordinate, you can fetch any color from inside that box. And hence, this is what the second input here is for of the noise top, which is the noise coordinate map. So there you specify all the lookups into this noise. Before doing this, let's turn the monochrome off, the monochrome parameter of the noise, so we get a nice colored noise. And now we have to get our 3D coordinates, the noise coordinate map. And these coordinates would be best to get from our template data, from our box that's subdivided. Now, we don't have a direct way to go from SOPs to TOPs, so we have to go via CHOPs. And the right chop for this would be the SOP2 chop. There we go. Sub2 chop. Now we have to convert this chop into a top. So I'll first put a null there, because I always do this. Add chop to top. And this chop to top by default now creates 3 rows of pixels. This is because the data format is set to R. So the red channel only is created. Now, as it has 3 channels as an input, it's going to create 3 rows of data. So let's change this to RGB and put this into the second input of the noise top. And if we compare these two things, then in the chop2 I can see it has a resolution of 64 pixels by 1 pixel, but the noise top is still 256 by 256 pixels. An easy way, without having to change the resolution of the noise top here on the comment page, I could also take the my coordinate map, basically the positions of each point of this cube, and put it into the first input. Now you will realize that there is something similar to the input here, to the colors and the noise output, and that shouldn't be. What's happening is that on the output parameter page of the noise top, you can see that the RGB is actually set to input plus noise. So what it does is it takes the chop2 top, or the first input here, and then adds whatever the noise is, whatever parameters you have set on the noise page. Now, this is not what we want. We just want the noise. So you can change the RGB parameter on the output page from input plus noise to noise. Okay, so this is good, and I'll put a null here as well. And now we kind of want to apply these colors here back to these points. And this can be done, again, not directly. We don't have a direct operator that goes from subs to tops. But we can do this via chops again. So the chop we will use is the chop2 sub. So between the box 2 and the copy 1, I will be adding a chop2 sub. This one expects a chop. Hence, I only have a top here, so I need to go back from tops to chops. So let's create a top2 chop. And this top2 chop I'll place here. It wants a top as a parameter, as a reference, so I'll add that in. I don't need the alpha channel. Actually, I might need it, but yeah, sure, let's keep it in there. And then what I'll do is I'll reference this top2 chop with at the chop2 sub. So take this null and apply it to the chop2 sub here. It's giving me a warning, the chop2 sub, saying channel TX, TY, TZ not found, which makes sense. My channels here are called RGBA. So in the parameters of the chop2 sub, I would have to change the channel scope from TX, TY, TZ to RGB. And under the attribute scope, I don't want to adjust the positions of each point, which it currently does. P is an attribute of the geometry, which means the positions. What I rather want to do, and I can kind of explore that if I click on this little drop-down menu behind the attribute scope parameters here, I can see, okay, it has point position, it has point color, point normals, point texture coordinates, and those point color attributes are exactly what I want to control. So instead of P0, P1, P2, I would want to have CD0, CD1, CD2. So let's change that parameter here as well. CD0, CD1, and CD2. Okay. And here my gridded box, subdivided box now has colors. Last but not least, it is not yet applied to each box of in my copy sub, and I can do this by turning on use template point attributes. What this will do, it will take all the attributes of each point and actually apply them to each copy that it creates. And there I go. I have a box with many different colors. Each cube has a different color fetched from the noise top here. Okay, and this is still good, but let's do what I have in my little component that I showed you earlier, just as a reminder what it did here. Let me turn playback on. So the noise was moving through this box. And to do that, I animated the noise. And you can animate the noise easily on the transform page of the noise tab. You have the translate X, Y, Z. So in the translate Z, let's type, and I'm just going to open up this parameter so I can type better into the TZ section of the translate parameter. Let's type here abs time, and that's ABS capital TIME dot seconds, and then because it's probably too fast, times 0.2. And now I can see that my noise is animating. So currently, this is fairly fine. My CPU cook time here is 1 millisecond approximately. I have 4 by 4 by 4 boxes, 64 points. But now let's try something. Go to the box 2, to our template, and increase the divisions from 3, 3, 3 to 13 by 13 by 13. And I can maybe change the scale a little bit so it looks better. So I see each box individually. There, nice. But now if I middle mouse click onto the copy sub, I see, oh, this is not so good anymore. This is now actually taking up 30 to 40 milliseconds per frame. So way out of what's possible to, like I'm oversaturating here my allotted time for one frame by quite a bit already. So this is not a solution to our problem, to our to what we want to build, to our cube with a lot of other cubes. And despite it doing the same thing, it's just way too slow. But this is exactly where instancing comes in. Instancing allows you to take your copy data, your box, move it onto the GPU, and then copy it on the GPU and apply all these attributes on the GPU to it, which is much more efficient and allows you to create much more complex systems, therefore. So let's save this here. What I would do is I would just select everything, right-click somewhere on the pane to bring up the pane menu, and then select collapse selected. What this does, it puts it all into a base component, and let's call this base component copy sub. Great. I mean, the copy sub in general is a really interesting operator, and I don't want to discredit it in any way. It is a lot of fun to play with, especially when you put parametric data into here or use stamping as well to change, because stamping allows you to go backwards. So you can change the attributes of your copy data per copy as well. It's really a lot of fun to play with. Would encourage you to just play with it on its own as well. But for what we're trying to do now, it's not really a good solution. So let's try to set up the same thing with instancing. Now, instancing is done on the geometry component itself. So perhaps a good way to start here is to go to the palette. If you don't have the palette open, it's this second little icon here right under the file menu. If you roll over, it says open palette. And then in the tools section, there is a component called arcball camera. And let's take this arcball camera and drag it onto our pane, network pane. Now the nice thing about this is that we already have render set up with the ability to actually interact with the rendered image on the component level. Let's go inside here. We are inside arcball camera now, and there we can see we have a complete render setup. We have a camera which comes with a couple special custom parameters and special functionality, which is all the tumbling and things like that. A geo component with a box input and a movie file in and a phone material. So this is all great. We do need this box this is our copy data, and instancing, as I said, is being found on the geometry component itself. You have two parameter pages here, which is the instance parameter page and the instance 2 parameter page. As an instancing source, and just comparing this with the copy sub, the instancing source would basically be kind of our template data. As an instancing source, we can use a chop, a dat, or a sub. So the easiest perhaps would be, again, to open up the upgrade dialog and create a box right here. And I'll just append a null to it. And now turn on the box, turn on divisions, 3 by 3 by 3, that's great. And let's drag this null sub that I appended onto the box sub onto the instance chop.sub parameter. You might have realized I turned instancing on to make this parameter available here. So now we have instance chop.sub referencing our box with the subdivisions. And now all the other parameters also become available. Translate x, y, z. If you look on instance 2, there's also color that can be the color attribute here that we can control. So we have everything that we need to create our little, the same thing that we did with the copy sub, basically. So now for translate x, y, z, click on the little arrow after the translate parameter, and you can see that you have the same parameters here that you can fetch. P0, P1, P2. The same as we had in the chop2, no, it's not true, in the, yeah, chop2 sub, that's correct, yeah. So that's good. We can create very quickly a little instance geometry and render it here. 4 by 4 by 4 boxes with they're all shaded with the movie file in. Let's actually remove the texture here, the color map from the phone material. So click on the phone 1 material and under color map, remove the null 1. Great. We want to color this ourselves, so this is perfect. Let's delete this. Now let's see, how would we get color onto the whole thing? Same workflow as before. Let's create a noise top first. The noise top will turn monochrome off. And we need, as an input, we need the noise coordinate map. The noise coordinates we can get from our box sub. So we have to create a sub2 chop. The sub2 chop needs a sub as a source parameter here. And we get our positions. These positions, which we now have in chopland, will have to be converted into a top. So I apply null or append a null to the sub2 chop and add chop2 top. This chop2 top, again, it creates 3 rows of pixels, 64 pixels width and 3 high, and this is because of the data format set to only to use or create a red channel, but we can change this to RGB and plug this in the second input. Now again, remember what's happening here. While our input is 64 by 1 pixel, our output is 256 by 256 because it's using the first input as the source for the resolution. Or, well, actually, yeah, that's what it is. Use input or a custom resolution. So when plugging the chop2 top into the first input, it actually creates our 64 by 1 resolution for the noise top as well. Last step here, output, we did this before. On the RGB parameter, it's input plus noise, but we just want the noise. We don't want the input applied to this. So fine, how do I now get this into instancing? I can specify chop, dat, or sub. I specified a sub, and now I have two other options here. The best probably for us to do here would be to convert the noise top back into a chop, then merge it with our positions that we have in the sub2 chop, and then use the chop, the one chop, to specify the translate and the color attributes of these instances. So let's do that. I'm going to middle mouse click on the output of the sub2 chop, create a null chop, and reference this null chop instead of my null sub that I had previously as my instance template, so to speak. Now it's warning me that the instance attribute P0 could not be found. P0 is a point attribute, so it's getting this from subs. We now have channels, tx, ty, tz. So translate x, translate y, translate z has to be changed to tx, ty, tz. And you can always have a look what's available by clicking on this little menu at the end of the translate parameter here. Okay, we're back at this. Now let's convert our noise top into a chop again. Put a null there. Create a top2 chop. Reference the null top that comes from the noise as the top in the top2 chop parameter. And in between the sub2 chop and the null chop that I'm using as my template chop for my instancing, I'm going to add a merge. And I can add in operators in between two other operators by either right-clicking onto the wire that connects these two operators, or also actually right-clicking on the input of an operator. This is sometimes easier than clicking onto the wire that connects two operators, easier to hit. So the merge chop now takes almost unlimited amount of inputs here, and I can use my top2 chop as a second input to it. And let's clean this up a little bit so it looks nicer. Okay, done that. And now looking at the instancing pages again, I now can go into the instance2 page and specify as my RGB colors the RGB channels. Okay, that's good. And let's animate the top, the noise top. So click on the noise top, go to the transform page. I'm opening up translate, the translate parameter, and type into the TZ. You can also use the TX or TY parameter, it really doesn't matter. Apps time with a capital T, dot seconds times 0.2. Okay, I'm going to adjust the period a little bit, just so we can see this movement of the noise better in a moment. Like, let's set it to 10. Now, so far, this is all the same, but I can now increase my divisions without my frame rate being affected much or at all. I have to say my frame rate is a little bit low here, and this is because I'm running this recording program, which seems to impact my video card's capabilities quite a bit. But yeah, I mean, the difference is quite extreme. You don't have the same impact, and I can create way more copies. I now create 13 by 13 by 13, but I can do, perhaps by disabling this and decreasing the box size quite a bit, I can go way higher without really, well, actually, this is funny. I created now so many that my tops are clamping. Number of samples exceeds texture resolution. So I have to go down there a little bit. 73 by 73 by 73 maybe has been a little bit ambitious. So, but 23 by 23 by 23 already, it's a lot of boxes, and my frame rate is pretty much the same as it was before. Here we go. So this would be impossible to do with SOPs, just for the fact that, yeah, the CPU couldn't handle it. I mean, when we had 13 by 13 by 13, we had 40 milliseconds. So just imagine what it would be now when using 23 by 23 by 23 divisions. Yeah, I guess the last thing that what I did here was, it's a neat little idea or trick. We could change the scale by the luminosity of, or the luminance of the noise top values. And there's a really easy way to do this. The reorder top comes to mind here. So right click on the output of the noise top and create a reorder top. And now the reorder top lets you take multiple inputs and then assign these inputs color channels to the outputs color channels. But besides doing red, green, blue, and alpha, what you also can do is you can actually choose luminance. And since we're not using the alpha channel, I'm going to use this channel and save luminance in it. So it takes RGB, takes the luminance of it, and applies it to the alpha channel. And this alpha channel I now will use as my scale factor for each box. So on the first instance page of the geo component, we can apply scale X with alpha, 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 scale X, Y, Z. And I'm going to increase my box a little bit. There. That's good. And you can see that I basically created the same thing as we created before in the example that I showed you. It looks a little bit different actually. You could use a constant mat here instead of a Phong, or just set the emit to 1. I would have thought, no, not true. Constant to 1. Yeah, set the constant to 1. And you get the same vivid colors that we had in the example I showed you before. Now, okay, so this is good. It's still a little bit like you have to go around quite a bit, like take SOPs, convert it to chops, use tops, convert it back to chops, and then use it for instancing. So the next step for us would be, after we save this file, the next step for us would be to open up the same file in the latest 30,000 build, the latest experimental, and have a look what has changed in instancing that makes this process a little bit more convenient. So, let's save this. I'll save as. Gonna drop this on my desktop. Instancing. This obviously you can call whatever you want to. I already have an instancing here. Let's just underscore 22 or something. Okay. So I opened up the file that we just saved in an experimental build. This one is the 2019 33020. That's the latest one that was published on the homepage as of November 1st. And let's have a look what changed with instancing. So there's quite a bit more parameters here. The thing is that now there is a default instance up, but I have for each attribute I actually have a separate op that I can specify. So my translation and my scale and my color could all be driven by different ops, by different operators. So we can simplify this network by quite a bit. I could use my SOP, my template SOP, which is the grid here. I could use this as my translate operator. Again, it complains a bit because it's now cannot find the TX-TY-TZ channel. I'll fix this, P0, P1, P2. My scale, I could just get from the top directly, skipping the top to chop here. The top to chop, which is always a little bit expensive. So let's take our null top that comes after the reorder top and use it for scale. And on the instance 2 page, for the color up, we'll use the same null top, RGB. And I should still delete the null 3 chop here that was referenced there. And I can delete these 3 chops. And I have a much simplified network here. So the biggest thing for the new instancing in the experimental series is that we can have separate operators or individual operators for each attribute that can be adjusted. Translate can have its own, rotate, scale, pivot, all its own. The other nice thing that is new here, not something we're going to use here, but there's a third instance page, and this one has custom attributes. So previously, what you might have done when you worked with instancing was that you would save certain data into, I don't know, I often save data into the texture mode, into the W coordinate, because I usually didn't use it. This is not necessary anymore. You can actually have your own custom attributes and then use these when writing GLSL materials or something like that. So this is a really nice addition here that makes it easier, less complicated to build instances. Okay, so this concludes the first part of this workshop on instancing, and we'll continue with building a little universe as a point cloud or from a point cloud file next.